Oh, no, more algebra kind of stuff today. So there's the graph of the DOM. Today we're going to keep looking at different little algebraic parts of functions. Today we're going to start out by looking for domain. Who can define domain for me? Yes, it's the same word that we already used. What were we using it for before? Who can describe that to me? When I said find the domain, what was I asking you to find? The x values, that's right. Now, when I don't show you a picture and I just give you a function and I say give the domain, the default domain for any function is going to be all real numbers. The default domain is all real numbers. What you're essentially telling me is what is not in the domain. What can't we plug into this function? That's essentially what you're going to be telling me, and then we're going to write it in terms of it's all real except for blah, blah, blah. So, like number one, well, actually, before we get into specific examples, that I can think of, the only two things that you've been taught you cannot do in math. You cannot have a what in the denominator. Zero. You can't have a zero in the denominator, and you can't have a what under a radical. Say it again. Negative. Those are the only two things you have to worry about. Zeros in denominators, negatives under radicals. If your function doesn't even have either of those, you don't have anything to worry about. It's going to be all real numbers. Number one, is there a radical? I say radical. Cube root wouldn't matter. It has to be an even radical, but I'm pretty sure all the ones we're going to do are going to be square roots. So, anyway, does this have a radical or a denominator? No. So it's all real numbers. Which you could write as negative infinity to infinity. You could write all real numbers. Whatever. You could write it in step builder notation. I'm just not a huge fan of that. Number three. What can't x equal? 4. Right. Now there's several ways you could tell me that this thing has an exclusion of 4. You could say that the domain is negative infinity to 4, and then 4 to infinity. Notice there's no brackets, so you've told me that 4 is not included. You could do it like that. You could say that it has all real numbers, and then put comma x cannot equal 4. Like, this isn't the answer to number one, but like this. Anything like that. Or if you're a fan of set builder notation, you can do it like that. I am not, so I'm not even going to look at it. But these are the two ways this is how you're going to see it on your test, I do believe. I'm pretty sure this is how they put it on the test. What's the only thing x cannot be in this function? What's the only thing that's going to give us a 0 in the denominator if we plug it in? 4. So, just like, imagine you were looking at the graph of this. And let's say right here is x equals 4. Please don't ask me to. And I asked you what the domain is of that. You'd say, well, negative infinity all the way up until this gap at 4, and then 4 to infinity. That's not exactly how it would look. In fact, this one would have an asymptote. I just sketched something. But that's where it's coming from. Number 5. Do we have a radical, a denominator, neither or both? What does that mean? All real numbers. Good. If you don't have a radical or a denominator, you don't have any problems. Number 7. Uh-oh. Looks like we have to do some factoring. Dun, 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 dun. Anybody here remember how to factor? Who thinks they can factor this thing? Of course, you could use a quadratic equation as well, if that's what you prefer. Did you have it? Very nice. X plus 3, x minus 5. Very good. So what two x values can we not have here? Negative 3 and 5. So the domain answer would be negative infinity to negative 3, negative 3 to 5, 5 to infinity. That's showing there's two breaks, one at negative 3, one at positive 5. What about number 7? We just did that one. What about number 9? Yeah, say it louder. -7 and +9. Yeah. So this one, like this. All reals except for x cannot be -7, +9. It's probably... Nope. Not unless there's a radical. It will not affect your domain. Only problems we have are denominators and radicals. Nothing else. What about number 11? I'm sorry? 1 is one of them. All reals except for x cannot be 1 and what? And -1. Very good. What's going to make this guy equal to 0? What could we possibly plug in for this? That's a real number. That would make this 0. Now just this first piece. Nothing. Because no matter what we square, it's going to be positive. So there's nothing we could square and get -1 that's not imaginary. We're not even going to get into that. So this one we don't have to worry about. Nothing could make this thing 0. This one could be. 1 squared would be 1, and -1 squared. Or you could have factored it to x plus 1, x minus 1, and looked at it like that. But, yeah. So anytime you have an x squared or x to the 4th or anything plus something, it's not going to cause you a problem. Because that can't be negative. But if it's minus, well, that's a different story. What about number 12? Very good. 2 squared would give us a 0. -2 squared would give us a 0, and this one doesn't cause us any problems. So, -infinity, I'll answer this one like this. -2, -2 to 2, and 2 to infinity. I'm sorry? Thought I heard something. Nope. Okay. 13 looks fun. It's a fraction in a fraction. What jerks? How'd you get 0? Yeah. If you put in 0, you're going to have 3 over 0 problem. And then you're also looking for what's going to make that whole thing equal to 0. So, the easiest way to solve that, which Josh did in his head, kudos, but the easiest way to do that would just be to set the whole denominator equal to 0, add the 1, multiply by x, and x equals 3. So you'd find out the two things that cannot be are 0, which is that piece, and by solving for the whole denominator, 3. So everything but 0 and 3. 15 will work the exact same way. Somebody else try to tell me, work on your paper, and tell me what the answer is going to be for 15. 15? What can't be in that little bitty fraction? That's one of them. And then what's going to make the whole thing? Very good. 1's the problem here. And then if you plug in 3, it'll be 4 over 2, which is 2 minus 2 is our other problem. Again, I see we've got some people who really like to do mental math. That's awesome. If you're not seeing where they're getting this, again, just set the whole thing equal to 0. I say the whole thing, the whole denominator. So it'd be 4 over x minus 1 minus 2 equals 0. And that's how they came up with the 3. Add the 2. Well, I'm not just doing this. Add the 2 to the other side. Multiply the x minus 1 over to the other side. That gives you 4 equals 2x minus 2. Add the 2. Divide by 2. And x does equal 3. Boy, I should change colors. Looks like a whole lot of writing. I should change colors for a problem. Oops. So now, before we do 17, because it's obviously different, are there any questions about 1 through 15 where we are looking to find these answers or how we're getting them? What makes 17 different? It's radical. Now when it comes to radicals, you can have a 0 under a radical. You just cannot be less than 0. So essentially, you're going to kind of be doing the same thing you did with the denominator. You're going to be setting it to equal to 0, not because that's our problem, but because everything that's going to make it less than 0 is our problem. So, I'm just going to take this problem elsewhere because we are low on space. Ooh, 17. Just take what's under the radical, set it equal to 0. Or if you want to go ahead and cut to the chase, you know that this has to be greater than 0, right? So, I'm trying to think of the best way to do this. We know that this has to be greater than or equal to 0. So really, just solving this thing for x will be our domain, because it has to be greater than or equal to 0. Add the 3, and this function's domain is x has to be greater than or equal to 3. Anytime you have a radical, there's going to be an inequality in your answer. And most of the time, it'll have an equal sign. 99% of the time, it'll have an equal sign. The very rare case where it won't, we'll go over in a minute. But so basically, you just set what's under there, greater than or equal to 0, solve, domain. Questions on that guy? Because it has to be positive. You can't have a negative under there. So that's why you will always set it greater than or equal to 0. Did that answer your question? Good. All right. Here's some more. We'll come back to I apparently took the numbers off of these. We'll come back to that top one, because that's a problem and a problem. Let's look at G or F. Which one do you want to look at, G or F? G, first thing I heard. Okay. So, just like the last one, you take what's under the radical, make it greater than or equal to 0, and solve. Divide. And when you're finished, that is your domain. That was this one. I guess I should draw arrows since there's no numbers. That was this one. Bless you. Questions on that one before we move on to another example? Okay. Let's go back up and look at that top G for a second. Now this is an interesting problem. Why? Yeah, you have both. You have who said that? Oh. I heard the voice coming from there, but it was so soft I wasn't sure my depth was. You can't have a 0 in the denominator, and you can't have a negative under radical. So first things first, what's going to make that thing equal to 0? 3. X cannot be 3, or you could do the negative infinity writing. I don't really care how you do it. But what's the next thing we have to do for the radical? Very good. I'm setting up the problem. So I set that whole thing, and what do I get? X has to be greater than or equal to 3. Now, remember how a second ago I said 99% of the time you'll have an equal sign? That's because you'll always set it up with an equal sign. But what did our first statement say? X cannot equal 3. So, now I guess you could just write those next to each other, and you wouldn't be wrong. You would have just written too much. Another way to just do that is take away the equal sign. Now, you take this. Does both of them. X has to be greater than 3. I don't care if you just want to write X cannot equal 3 and X has to be greater than or equal to 3. I mean, it's a little contradictory, but I guess I wouldn't care. But this is the way to accurately just say both. Has to be greater than. Questions? All right, let's look at H. H is interesting. Take a second. Don't just blurt out the answer. Take a second and work both parts of H, and then I'm going to ask you for the two answers. Nobody blurt it out. Who thinks they can tell me the two inequalities here? Listen. Very good. Now, this problem is unique because the book is not going to tell you that's the answer. Who thinks they can tell me what the book's going to tell you the answer is? Yes. Why? That's right. That's right. This satisfies both. Anything greater than or equal to 2 is also going to be greater than or equal to this one. But there are things that satisfy this one that don't satisfy this one. So therefore, that one is the only one that you can plug into both equations at all times. So this is what the book would tell you the answer was. Whenever you have two inequalities in your answer, and they're both the same, greater than or less than, if they're both the same, then one of them is going to encompass the other one. If you're greater, it's going to be the bigger one. If it's less, it'll be the smaller one. Isn't this fun? What about G? Anybody want to just take a stab at G, other than Joey and Josh and Alyssa and Troy, who've been telling me most of the answers, and Shelby? Other than those 5 people, which is 20% of the class. I think I'm getting a strong vibe. This problem feels like it wants to be answered by he. The problem chose you. What do you think? Brilliant. Very good. Now, technically, the problem said what is the domain, not what isn't the domain. But that seems to be the natural way to answer this. Actually, that's pretty perfect anyway. I was thinking all real thing. This says everything. Greater than or equal to 2, that's perfect. I take back whatever I was going to say. Perfect. Questions on that problem? Who thinks they can tell me what the trick to doing F is? What's the trick to F? Factor, yes, but factor how? Ooh, Troyan gave me this. And I know that means she knows what she's talking about, but unfortunately I've disqualified her from answering this. She's too valuable to this team. We need other people to step up. Say that one more time. You can't factor just part of a polynomial. Well, I guess you could put it in parentheses, but you would still be kind of left with some of the same issues. But actually, you're on the right track. By breaking it into pieces, you're on the right track. You can take what he said and run with it and tell me what Troy was meaning when she did this. Sorry? Separate it. What's the official wording for that? Factoring by rhymes with pooping. Grouping. Factoring by grouping. I don't see why that's so fun. All right. Now, so you were kind of right when you said do a part of it, but you have to put them in pieces. Now, one thing you have to be aware of, when you factor by grouping, whenever you factor a minus sign out, see how the minus is out there? You have to change this sign. Because originally, that minus sign had nothing to do with the 20. But by factoring it like this, now it would technically distribute. So if you were to take these parentheses away, it would be minus 4x plus 20, which is what it originally was. So anytime that middle sign's a minus, don't forget to change the last one. Or you're going to, of course, I'm sure you'll be reminded of that when your stuff doesn't work out if you don't. So, Austin, going back to what you were saying, what factors out of just this first binomial? Very good. What's that leave you with? X minus 5. Minus, what factors out of the second one? Drake, what factors out of the second one? 4, which leaves you with? Very good. Again, remember, if you had forgotten to switch this and this was a plus 5, you should have a red flag going off. Because these should always be the same when you factor by grouping. That's what I was meaning by you'll figure it out when it doesn't work later. Okay. Who remembers from Algebra 2 how I rewrite this? Wow, you're a step ahead of me. I was meaning, how do I group this stuff? Well, let me ask you this. If I had 3y minus 2y, what would I do? I would just subtract. They're like terms. These are like terms. So I can just subtract their coefficients too. X squared minus 4 times x minus 5. Now, Jared, can I factor this any further? X plus 2, x minus 2, just for that first piece. Yes. You could also. Wait. Which part are you referring to? Yes. Yes, you could. But she said you could also use synthetic division. The reason I'm not doing that is because we're going to actually do like a whole chapter that uses that. So, but yes, if you remember this, by golly, just go for it. Wow. Who was your Algebra 2 teacher? Never mind. Okay. Well, I will not compliment him then. Okay, so all you've done is factor your denominator into this. So now it's 2x plus 7 over this, but this is much easier to pull out what x cannot be. So x is all real numbers except for what? What can x not be here? Negative 2, positive 2, positive 5. All real numbers except for that. Questions? This is a long section, and this is Friday, so I think we might just cut this thing in half. Okay, so I have to change this assignment. We're going to call this. Go ahead and get out your homework paper and label it. Well, I have to change this first. Let's see. I obviously have to change these numbers. We're going to change this to even since I'm cutting the material in half. And the numbers, I have to flip to page 229 and look for myself. Why are you mocking me? That's bullying. And I have it on camera. So you just bullying. You're right. Technically, the difference of bullying is repeatedly. 30. Oh, I just did that one. No, I didn't. Okay, good. There we go. 2 through 30 even will suffice for today. Please label this 1.7 part 1 or point 1, whatever. Because we're going to do 1.7 part 2, bless you, on Monday.